Okay, the intent of this presentation is kind of just get some feedback about how many OEMs, software developers, or end users are interested in the interfaces, which was done back in, what, 2018? And so most of this is just going to take you back to some of this. And also, I'll show you some use cases in the beginning so we understand the intent of this. Will already did a introduction, so I'm going to skip this. Okay, the topics are job shop automation today, robot to CNC interfaces, what robot community would like to see from MTConnect, introducing the MTConnect Part 5 interfaces, Part 5 history, and continue the development of this particular part of the standard. We'll end with some questions and answer times. All right. This is one of our products. It's just basically a lathe with a collaborative robot. Uses a digital I/O interface. It's kind of where everybody should start. This is an industrial robot. I did this back in 2017 with one of our small machining centers. And the next one is my run overnight project was pretty involved. It used a Siemens control for the CNC and also a Siemens control for the robot. What made this challenging, we're doing 3 operations, kind of the op 1, op 2, op 3, which is basically the front, the back, and one side, using the robot to move the part through the 3 fixtures and back and forth to the grid plate. It's kind of a fun project, but it was pretty fruitful. And we learned quite a bit. And actually, I drove some of the data collection into the parts and process. When I do my meetings with managers and owners, I always use my MTConnect dashboard to describe machine utilization. So this particular subset goes back to September. And between the 2 red lines is basically our normal working hours. And over in this section here is basically the run overnight unattended. So you can see we come in the morning, we update the machine by taking off the finished parts, cleaning the machine and putting in some raw stock, and we get basically 20 to 22 hours of runtime most days. Next 2 machines are from Fifth Axis down in San Diego. Just describing here where the automation is basically fully integrated into the machine. So I think it was a Micron machine. This is a Grove machine with an Eroa pallet changer. And so what I just described is kind of from the simplest form of automation to more or less the high end for where we are today, specifically for job shops. Market segments that I kind of singled out was the do-it-yourself group. You know, they already have a CNC. They purchased a newly used robot. They watched a few YouTube videos and downloaded the manuals to figure out the interface themselves. So you'll find a handful of videos on YouTube. Next group is the third-party integrators. Usually they're a robot dealer. They have experience with connecting robots to CNCs. They may have developed their own robot interface scheme. They're very creative with machine tending related products. They face technical challenges with each machine type. So it's a pretty big job to go through that. So I just call that ad hoc interface. Latin, that means for this particular situation. And of course, the high end, they're fully integrated, but they're mostly too expensive for our particular part of the market that we sell into. The interfaces, I coined this robot as a human, where you use the robot to open the door, remove the completed part, replace it with the raw stock, and press the cycle start button. So that's robot as a human. The next group is I call circuit splicing. This is probably the worst nightmare for OEMs, where we're basically tapping into the circuitry of the cycle start connection, and also tapping into the circuitry of the stack light to basically get a cycle complete signal feedback. And actually, this is my stuff. This is primarily why I've kind of focused on this topic. So that first robot implementation I showed you, this is kind of the wiring for that. So you have a bunch of digital I/O wiring, from the robot back to the CNC. Within the CNC, you have connections to a terminal block. And in this particular case, we had to modify the PLC software in order to support some of the interface signals that we needed. And herein lies the nightmare. When people say Ethernet is just all over the place, with lots of different protocols and APIs to be able to connect to it. So there's no standard protocol, vocabulary, or definitions. There are a couple of proprietary Ethernet interfaces. At the Automate show last May, FNUC was showing their QSSR, which is quick and simple startup robotization. And LNS has had their eConnect software product out for quite a while now. So those are only two that I know that are commercially available. But it's very limited to, I think for the FNUC, it only connects the FNUC CNC to a FNUC robot, and they have specific models that it supports. And I think the LNS, again, it's basically intended for just the LNS bar feeders and their other companion products that they make. Okay, now what do we want, robot guys?
I'm founder president of Versatile Robotics. We make automation systems for targeted high-mix CNC manufacturing. So for the automation system that in a lot of parts. We've done hundreds of CNC innovations. And the thing that I would really love to see out of MTConnect standard for is at a minimum, the ability to read and write macro variables. The right portion is very important. And ultimately, we love to have a standard way to select the program on the CNC right to start. But just being able to read and write macro variables gives a long way to having good solid integration. All right, thank you very much.
Okay. That was from a OEM perspective, third-party integrator. And this one is from Predator Software. Actually, they have a published list of, for all the OEMs of the interface that they would like to support all the functionality that they have in their software. The list is too long. It's actually a couple pages. But nevertheless, there's a robot part of that, and there's a CNC part of that. And also, a term I'm going to use is closed loop manufacturing, is where the robot moves the part from the CNC to the CMM. CMM does a measurement and comes up with some modifiers it needs to make back to the CNC. And so that's what they're describing here with work offsets and tool length offsets, is that functionality, which doesn't exist in a standard form today. And for me, I'm kind of on the cell controller bandwagon, where there is a centralized piece of software that orchestrates these machines. And also, since I am OEM, I'd have to deal with safety. So digital I/O is not going to go away entirely in my mind. You're still going to have e-stops, enabling functions scattered throughout your cell to support the safety rules that still exist today. And then I'm using the term secure machine API. Security is big concern. But with cells, usually it's a private network. It's not a network that's scattered around that needs access for everybody in the company, just in that cell. So it's a little easier to secure these things. And we just need a MTConnect agent with secure response and MTConnect client with secure response. Okay, then let's talk a little bit about part 5. It's a document. I guess with each release of MTConnect, they roll up the version number, but I don't think there's been any functional change for quite a while. This is my summary. It supports a read-only interface, requires an MTConnect agent and client to be implemented on each device. Section 3.2 defines the request response protocol scheme for communication, defines the HTTP client requests. Section 4.3 defines a few data items. Again, I think this was done as just a proof of concept / demo project, so it wasn't really entirely comprehensive for all use cases. And then section 5.1 defines the failure and handling recovery. I didn't think Will was going to be here. He said he was moving, and so actually this is Will's 2013 videos posted on YouTube.
The system's architecture used MTConnect ROS industrial demonstration. Admins made use of the MTConnect read-only communication strategy. For devices do not directly control each other, they publish their state using an HTTP server, and the other devices perform actions if they are capable to do so. The demonstration reads a robot and a machine tool. The machine tool does not send messages to the robot. The machine tool requests data from the robot and the robot from the machine tool. For example, when the robot changes its open door state to active, the machine tool responds by transitioning its open door state to active. Once the door is open, the machine transitions to complete, and the robot acknowledges by transitioning back to ready. The roles are reversed when the machine tool makes its load material request from the robot. This is peer-to-peer communication. The benefits of this architecture are the ability to scale from single device to multiple devices, even different types of devices. When new devices are added, communication between devices is identical to the one-to-one scenario. This architecture easily extends support of many-to-many communication, which enables fault-tolerant processes that are driven by demand and availability, not a preset sequence of operations.
Okay, that was Will's explanation.
The system's architecture.
And did the same thing for Neil. This is back in 2011 at the Mazak event.
Hi, I'm Neil DeRosiers with Mazak Applications. Today, what we're talking about is the LNS servo bar feeder and the Mazak HyperQuadrex machine. We're presenting the first ever interface between these two devices using MTConnect. What we've done with LNS, our VIP partner, is develop the prototype vocabulary for this interface. So traditionally, a bar feeder in a machine has a digital I/O interface where it's a series of wires and yes/no signals, on and off signals, and its intelligence is limited. With MTConnect, we're using Ethernet as its protocol. What we've done is eliminated a whole bunch of hardware and wiring, and also enhance the vocabulary and the capabilities of the communications between the two devices. We can now send the remaining bar material length to the machine. The machine can send information such as, is the spindle still running? Is it clamped? What job am I running on the machine? So now more intelligent decisions can be made while the system is running. And now we can actually have the machine program reading that value and saying, if I can't make my normal part, that's 6 inches long, maybe I can make two 2-inch parts. So it allows us to utilize our material much better. Because we're eliminating all that hardware, implementing this connection or putting this in place and marrying it to a machine only takes an hour or so versus a whole day setting up all the digital I/O boards and the communications and such. This is the first of its kind ever done. We're showing it here today or at the T3 event at Mazak. Once we're done here with all of this prototype information, is going to get hashed out with the work group of the MTConnect Institute for accessories and blockers, and we'll get it finalized to standard on.
Okay, any questions before I go on? Okay, we'll just look at a little history. Well, you're on. First I can guess this went back to probably 2010 because the Mazak T3 event was in 2011. And it looks like the NIST funded project was in 2012. It showed up in the MTConnect standard in 1.4, which is back in 2018. And that same year is when the IMTS technology demo was shown. And since 2018, I can't see that anything's really changed. For Neil's video, he had 10,400 views, 14 likes. That goes back to 2011. This was the 2018 IMTS show technology demo, which was really front and center of the whole show. So a lot of people, I think, walked past this and also probably got a chance to talk to Will. I didn't know if this Ross industrial project where it went, but it was kind of that same time frame. This is in 2013, where they created a interface that used the MTConnect standard. Okay, and now this is where we are. We want to continue the development. But there's about 20 people or so on the call. Is anybody interested in seeing this continue?
Yes.
I guess that sounds like that's Eric. Give me some background of your level of interest and how you would use this or how you might want to change it to support whatever use case that you're trying to achieve.
So I don't necessarily want to talk about changing yet, but in terms of the use case, it's what you showed, but making sure that it works every time. Okay, so you saw my comment earlier on what Will had shown for Yamati, right? As we talk about what's the minimal MTConnect implementation to support different use cases, we really need to figure out is what's currently written into the robotics interfaces standard enough for the general use case of, let's say, closed loop manufacturing that you described, right, to start with that, regardless of whose equipment is being used, okay? So if I know that I want to do closed loop manufacturing, and it's going to involve a CMM, it's going to involve a CNC, and it's going to involve some kind of a robot, what is the minimum implementation that needs to be there, and how does it get validated so that an OEM can, or I should say, someone who's actually purchasing CMMs and CNCs and robots, right, can reference the appropriate guideline and say, you must implement this. And then I know when your equipment comes into my facility, I'll be able to plug it up and it's going to work in terms of being able to pick and place, be it open doors, be it make sure that the right chuck is in place, be it make sure the chuck is open, et cetera, right? The analogy I always use, everybody knows my semiconductor, people that know me, I talk a lot about, I've been in the semiconductor industry, right? It's a simpler thing because it's always the same kind of automated wafer transport system, but you can't sell a piece of semiconductor equipment into a 300 millimeter or larger fab that uses automated transport unless you conform to the appropriate standard. Because that way, that manufacturer of chips knows that when they put their piece of equipment in their fab, it will interface correctly to the automated product transport system. We need the same thing for discrete manufacturing.
Okay, so you're saying look at the chip interfaces as for some guidance?
Yeah, that's my personal experience, right? It's because that was done. There's basically 5 standards that go with that. describing the physical implementation, and then on top of that, the logical implementation. And an important aspect of it is the equipment being able to describe the state that it's in. And MTConnect can do all of that. Okay, so the question becomes, I think, really doing some more work to show that that there's a reliable implementation, and then also that the big roadblock with MTConnect is still the need to use read technology. I'm not against that. I think showing more use cases where read is used and works is okay. Now, whether or not that has to happen through MTConnect, or whether that happens through something with broader appeal across different industries, like MQTT, remains to be seen. But again, we need to I think still go ahead and keep the read or publish subscribe technology, and see if we can get vendors on board with implementing that. Now I will say, SEMI doesn't work that way, right? SEMI's been around a long time in the semiconductor industry, and it relies on old handshaking protocols that were originally written for serial interfaces. So there's a lot of rights, and there's a lot of hiring of very specialized integrators who know how to implement those SEMI standards to make that work. Right? We want to make it a little easier.
Okay, that's some good feedback. One of the pressing issues with kind of the projects I work on with our customers is where they want to have at least 3 devices, a CNC, a robot, and a coordinate measurement machine. And if you saw the overnight demo that I just shared with everybody, we have on-machine probing on that, so it is able to probe. Actually, there's one critical board that I probe every part, and we do modifiers to the offsets to maintain the tolerance. But there's also some dimensions that it can't do or use on-machine probing. And so now the question is, if I do have a coordinate measurement machine, which I have a couple of customers who are interested in having kind of a closed loop cell, I don't have a clue on how to write that software, maintain that software, and do the low-level interfaces. So I guess anybody out there see the use case where there's more than 2 devices that have to communicate amongst themselves?
Tom, and jump in just real quick. I mean, the other one that we're interested, I think, in pursuing right away, and we may propose a project for this, is mobile robot, right, servicing multiple CNCs in single CMM. That's, I think, a little more typical of what would be in a facility, right, where the ratio of CNCs to CMMs is not 1:1.
Yeah, that's a good one too. In my robotic group, we have one member who actually is working on implementing the read standard, and his ultimate goal is to implement mobile robots. So yes, that's another use case that's coming to us.
And I haven't been participating personally in the robotics group. I'm not sure who CCAM has, but we'd be interested in hooking up with whoever that is, Tom, offline.
Could you repeat that again?
Yeah, interested in connecting with whoever that is that you mentioned offline. We don't need to include it all here in the recording.
Okay, sure. I can get you his email. All right, anyway, the point of this whole presentation is just try to stir up some interest in the part 5 of MTConnect and see if there's any feedback in terms of the way the standard is written today. If we were to continue the development, we'd have to get some funding to support the software development. And so I'm just trying to see if this is a viable path to go down in terms of the interest and the ultimate value to individuals in the industry as a whole. All right. Guess you could send me your feedback. Okay, my email is tomc@trackmt.com. If you're not part of the MTConnect Foundation, you should join it. And you can join the standard committee, and then you can join one or more of the working groups. I guess, Russ, that's all I have. It wasn't a whole lot of discussion. So we have plenty of extra time. Guess any other conversations or comments about part 5? Okay.
Hey, Tom, somebody sent me a couple of separate questions. First one was specifically at TrackMT, what are you using as alternatives? And have you explored anything other than interfaces to accomplish the same things?
Most the complex one uses a Siemens platform, and Siemens platform is pretty flexible in terms of the way I can extend the software. But it wouldn't be anything that I would try to sell to a customer because it does require kind of in-house capability, and plus you have to understand all of the Siemens complexity. So, but I do use it to kind of figure out its value. And I did have a goal to run overnight unattended, and I basically just stuck with it until I got good parts coming out. And plus we're run 3 weeks out of the month, basically overnight unattended. So, so in terms of track, it's more or less just an internal project to sort out all the details to try to step back and see, if there's any opportunities in terms of the commercial value.
That was, I think you may have answered the next question, which was, does Track have a product offering that implements this now?
Not yet. We have a couple of customers we're working close with, kind of one-ofs, and at the same time, we're just looking to say how to transition these one-off projects to something that's more of a standard. Because I think it benefits everybody if we can sell more machines and sell more robots, especially to that do-it-yourself community, which are basically just trying to find their way without spending a lot of money. And the third-party integrators, we need their help to spend more time with just dealing with the variety of different kind of parts and not waste all their energy and trying to connect up a machine to a CNC. So it's just something they're working on internally for the short term.
The next question here was, I'm misreading. Do you see open source libraries as a major factor in the expansion of interfaces?
To step back with a lot of OEMs, I would suggest, even for my own company, OEM should be making APIs, just software APIs, and then on top of the APIs, build your, interfaces, whether they're one-of interfaces or to a particular standard, because software is difficult to maintain on a CNC, and a lot of times we have all these safety concerns. So we do not want to be changing the software because it takes years to test it and get comfortable that you have a safe product out in the market. So that whole industry needs to kind of get a wake-up call for, how do we support different protocols and be able to maintain the software without creating unsafe situations. You saw that where people are splicing your circuitry. I kind of cringe when I see that. So I did all the safety stuff for our European division, XYZ in England. And it's complicated. And so I think the scheme now is we're doing all the work so the OEMs can implement it sometime in the future. But that may be several years off. Did I answer your question?
Somebody had sent that one to me
Oh.
on the side. I have one question about your last answer. I guess this is a non-technical question. How optimistic are you about changes in support and interest, and I guess, modernization and interoperability among the vendors that you mentioned?
You know, we sell machine tools, and oftentimes one of the comments is, hey, I'll buy your machine if you give me an operator. You know, people just can't find people to operate these machines, and they're starting to get more interested in robots and other forms of automation to solve that problem. And it still takes a different skill set to implement automation. And it did, you know, my experience at Track, it did create kind of a culture change as well to get people to uh, you know, run these machines and not feel threatened by it, you know, that may take their job away sometime. But basically what I did is I opened up uh, the day for them to do something else while the machine was running, because what I kind of stumbled on is, hey, when you come in the morning, you basically attend your machine, which involves removing the parts that were finished, cleaning your machine, implementing the next set of raw stock, and also just checking to see your tool where you need to change a tool. That whole process was taking us about 30 to 45 minutes. And then after that, the machine runs all day and runs all through the night, and then basically run out of parts about 3 o'clock, 4 o'clock in the morning. And we repeated that cycle, you know, day after day after day. So that was kind of the regiment that at least made sense for us at our shop. And so when I saw that, I said, wow, you know, that's something that the industry should pay attention to. Just in terms of selling machines that are easy to automate. And I think that's the key, is how do we make these things easy, and can we use any kind of a form of a standard so someone can go buy a robot and go buy a machine and not have to jerry rig it together.